So multiplying polynomials. Today we're going to multiply a monomial by a binomial. Tomorrow we're going to multiply different types of polynomials together. Today we're just multiplying a monomial by a binomial. So let's start with example 1a. So if I have negative x times 9x plus 7, well, we've seen something like this before, but before the number out front was a constant. I don't think we've done a variable yet. It's done the same way. It's like a negative 1x. All we're going to do is we're going to distribute that negative 1x to everything inside of the parentheses. So first, negative 1x times 9, well, negative 9x squared, because we're going to add those exponents, right? And then negative 1x times 7, negative 7x.
Wait, why not squared?
Ah, good question. 7 doesn't have an x. So there's only one x. So if I were to write this out, I'll write it out. This one's negative x times 9x. And this one was negative x times 7. Right? Good question. B. So B, we're going to have to distribute twice and then combine like terms. So I've got x squared times x minus 3 minus x times 2x minus 5. All right, so x squared times x is x cubed. Because remember, we're adding those exponents when we multiply variables. And x squared times negative 3 is negative 3 x squared. All right, then the second one, I have negative x times 2x. Beautiful, negative 2x squared. Negative x times negative 5. Positive 5x, because a negative times a negative is a positive. Finally, we've got like terms here in the center. So what is negative 3 minus 2? Negative 5. So negative 5x squared. And we just bring down the other two parts. Example 2. Example 2 says find the GCF. What's GCF stand for? Beautiful, greatest common factor. We're going to find the greatest common factor in this polynomial. So we're going to look to see if those three terms, because this one has three terms, right? This trinomial has three terms. I'm going to look to see, well, what do these three terms have in common? All right, so to find the GCF of a polynomial, this is what I'm going to do. I'm going to write each term and find the prime factorization of each term. So we're going to start with 5x cubed, 25x squared, 45x. So is 5 prime? Yes, so I've got 5. And then x cubed is x times x times x. What about 25? Is 25 prime? No, what goes into 25? 5 times 5. And x squared is x times x. All right, finally 45. 45 prime? No. I'm going to do the birthday cake method on 45. Oh no. There we go. What goes into 45? What prime number goes into 45? 5. How many times? 9. What goes into 9? How many times? 3. So the prime factorization of 45x is going to be 5 times 3 times 3 times x. All right, so to find the greatest common factor, I'm going to look to see what do these 3 terms all have in common.
X.
All right, they all have x in common. Anything else? They all have a 5. So what they have in common, 5x, is my GCF. All right, example 3. We're going to use the GCF to factor a polynomial. So we're going to use the same method. You ready? All right, so let's do A first. So I've got 4x squared minus 24x. There we go. All right, so let's start by writing the prime factorization of each term. Now this is important. If it says minus, that minus is going to stay with the term that's directly after it. So that's going to be a negative 24. All right, so let's do 4x squared first. So 4 is not prime. What goes into 4?
2.
2, how many times?
2.
2, so that's 2 times 2, right? That one was easy. No birthday cake needed for that one. And then x squared is x times x. All right, what about negative 24? Well, I know negative 1 goes into negative 24, right? What else? Do I need to do the birthday cake on 24?
Yes.
All right. So I got 24. What goes into 24?
8.
2, because remember we want to stick with primes. So that's going to be 12. What goes into 12? 6. What goes into 6? 3 times.
So that just means a negative thing?
Well, I'm going to leave negative 1 out front. But, yeah, one of your other terms could be negative. But I don't want to do that in case that's what the other terms have in common.
Do we have to put negative?
Yes. And then there's only one x. All right, so what do these two have in common? All right, they both have an x. What else?
2.
A 2. Anything else? Don't they have another 2 in common? We got another 2. So I can factor out 2 times 2 times x. And what's left? So when I factor, I'm going to write what's left. So what's left in that 4x squared? X. And then what's left in that negative 24x?
Negative 1 times
2 times 3. What's negative 1 times 2 times 3?
3. 2.
Well, negative 1 times 2 is negative 2, right? Negative 2 times 3 is negative 6. All right, then I can combine here. What's 2 times 2? Move this up a bit. There we go. 4x times x minus 6. Bless you. All right. One more example. Y'all ready?
Yes, ma'am.
All right. Example B, same directions. We're going to factor. We got g to the 4th plus 24g cubed plus 12g squared plus 4g. Huh? 4g. All right, y'all ready? All right, so let's factor each term. So I've got g to the 4th. It's g times g times g times g. 24g cubed. Well, we factored 24 in just that last problem, right? So I can kind of steal that factor tree. I don't have to do it again. That was what? 2 times 2 times 2 times 3. And we've got 3 g's. With some practice, you'll be able to just recognize the common terms. 12g squared. Well, 12, that's just 2 times 2 times 3, right? Do we need to do a factor tree on that? I know that's 4 times 3, and 4 is 2 times 2. And then 2 g's. And 4g, well, what goes into 4? 2 twice, right? All right, so what do I have in common? G. Anything else?
A 2. Oh, no.
Because that first one doesn't have 2, right?
Yeah.
There we go. All right, so I can factor out g. All right. G times, what's left in that first term?
3g's.
3g, so that's g cubed. That second term, we have all of our numbers left, so that's 24. And then how many g's are left? 2, so that's g squared. My third term, we have 12. Bless you. On 1g. And my last term, we have 4.